Hello, dear traveler. Welcome. Welcome to the Sleepy Circle. My name is, well, that doesn't really matter, does it? What matters is that you're here, that you found your way to this circle, this quiet place we've carved out beneath the stars. The Sleepy Circle is a journey through the night sky, through myths and science, through ancient stories and modern wonders. It's a place where we slow down, breathe deeply, and let curiosity lead us into the darkness. Over the coming weeks and months, we're going to explore the cosmos together. Not with textbooks and equations, though those have their place, but with stories, with wonder, and with a kind of awe that only comes when you truly stop and look up. Tonight, we begin where humanity began, with observational astronomy. The things we can see with our own eyes, from our own backyards, if we only take the time to look. And what better place to start than with Orion the Hunter, one of the most recognizable patterns in the entire sky, visible from nearly everywhere on Earth, and carrying within his starry form secrets about birth and the magnificent cycle that connects them both. By the time we're done tonight, you'll understand what stars really are, how they're born from darkness, how they live, and how they die, sometimes spectacularly, planting the seeds for everything that comes next. So find yourself a comfortable place, dim the lights if you'd like, let the world outside fade away for a while. There's no rush here, no urgency, just you, me, and the infinite night, waiting to tell its stories. Are you ready? Let's step into the Sleepy Circle together and see where the stars take us. Have you ever stepped outside on a cold, still night, felt the universe breathing, and wondered if the stars were waiting to tell you their secrets? Tilt your head back. Let your eyes find that pattern. 3 bright stones in a row. A diamond of lights above and below. That's Orion's belt. The first hint of a celestial hunter waiting in the arms of the cosmos. But what if it's more than that? What if Orion is not just a picture, but a passage, a doorway through time, story, and stardust? Some say the stars are just stars. Some see instead a frozen legend, the ghost of a hero. But what if the truth is larger? What if every myth is a memory, and every fact a second heartbeat underneath? Tonight, let's wander together, hand in hand with ancient Greeks and modern astronomers. Let's let curiosity lead and see where the darkness and the light take us. So gather close, as people once did around firelight. huddled beneath a limitless sky. Tonight we ask, why do some stars shine for eons while others flare and vanish? How does a new star rise from the bones of the old? And what might the fall and eternal flight of a giant like Orion teach us about our own becoming? By the end, you may find answers not just in the heavens, but in your own story. Orion the Hunter, Greek stars and light years. Journey with me now, back to a time of gods and mystery. Who was Orion? Some say he was seeded by Poseidon, god of the restless seas, and Euryale, daughter of King Minos. Their strengths wound into muscle, bone, and ambition. Others claim he was stitched from pure celestial light, sprung from the longing in the cosmos itself. But Orion's true origin, whatever it was, passed into legend. Taller than treetops, stronger than any storm, he walked above the waves and tracked beasts that haunted even the gods. Orion was the sort of soul who seemed too bright for the world, a seed growing towards its wildest, tallest shape. And don't we all meet creatures like this? Or feel it sometimes in ourselves? A reach that aches to be noticed, longing to matter, to last. But here's a bedtime thought. Is greatness safe without gentleness? Can ambition grow unchecked and still bear sweet fruit? The pride that started it all. With every victory, Orion's legend grew. He hunted until the hills ran empty. He listened to praise, drank it deep, and began to believe not only was he the best, he was unmatched, untouchable. One night, Orion stood at the edge of the earth and shouted into the hungry wind, "I will hunt and kill every animal. I am the mightiest that ever lived." But the cosmos, like a wise old storyteller, whispers back to boast, "Be careful, every brightness casts a shadow." Gaia, who had watched everything grow and wither, heard his call. In her deep, stone-rooted heart, she felt a tremble, not just of anger, but of sorrow for pride that had forgotten its place amid the wild garden. The earth answered him as only the earth can. She raised a scorpion, ancient as the morning and dark as the soil, venomous as unchecked ambition, the seed of his undoing, sent to remind even the mighty that everything in the universe has a boundary. The sting of mortality. The contest was swift and fierce. Arrows against armor, sword against the chitin curve. Orion twisted, struck, but the scorpion was patient, born from the silence beneath the roots. And so, in a single moment, the sting found him. Orion, who had believed the world was his alone to master, collapsed, his legend folding into humility. as he faded, a friend was left grieving. Artemis, the moonlit huntress, knelt by his side. She couldn't rewrite the story, but she could ask for a different ending. Father Zeus, she pleaded, let Orion be more than an ending. Let him be a sign. Place him in the sky, not for pride, but for memory, so all who look up might see both ambition and what follows. Zeus listened. He gathered what remained and scattered Orion among the stars, his figure shining, a warning and a wonder against the endless night. But the story did not forget the scorpion. It too was woven into the sky, set opposite Orion, so forever after, the hunter rises only as his lesson sets. And if you listen as the stars blink, what do you hear? A balance. A reminder that every light is born from a dance with darkness. So, what were the old storytellers trying to teach? That power, left unchecked, outgrows its garden. That life, no matter how bright, bends eventually toward the same night. And that greatness, too, is only a part, never the whole, of the world's wild web. But here is the secret. When the Greeks gazed up at those stars, they had no way of knowing what we do now. The stars of Orion were not unchanging. They were not forever. They were seeds, cosmic eggs, each hatching, burning, and sometimes dying. They watched for endings. Science tells us they were watching births too. So we return. Why do some stars last while others flicker and fade? What does Orion, the hunter turned into a sky story, whisper to us about what it means to fall and perhaps to rise again? The reality, what is the Orion constellation? When the cold returns and the sky is clean, you might try finding Orion yourself. Trace the belt, the sword, the upraised arm, a pattern written not by accident, but by 100 generations retelling the same bedtime story. Yet, imagine this. If you could fly just a little to the left, the pattern would break apart. These stars are not close together as they seem. They are scattered. Some only a night's journey light would take centuries to cross. Others so far the light left when Egypt was young. Orion is an illusion, a cluster of lamps in an infinite room, painted into shape by where you stand. But let's linger a moment below the hunter's sword. There you'll find a wonder, the Orion Nebula. Peer through a telescope and you'll see not emptiness, but a cloudy egg, glowing from within, alive with star sparks amidst the swirling dust. It's as if the universe is busy cracking shells, hatching the next generation of suns. The Greeks seen Orion's death didn't know they were looking at the place where stars, like butterflies from chrysalises, come to life. That sword holds a mystery, ancient loss above, ancient birth below. And those bright stars in the hunter shape, let's meet them. Rigel, a light so blue and quick, burning its life like a match, soon to go out in a supernova's last gasp, a fire that may already be on its way to us. Betelgeuse, swollen, red, uncertain, its surface rising and falling like breath. It may vanish any night in a blaze that would write a new age in our sky. The belt, Elnatok, Elnalam, Mintica, are themselves young and massive, their lives already halfway spent, while new stars are still hatching just beyond them. The lesson? The sky is neither memory nor dream. It is both, a place of endings, beginnings, and stories retold with every return of winter. The science. How do stars form? So, now we come to the question that hums beneath everything. How does a star get born? Imagine this. In the beginning of every star, every light, there is darkness. Not the darkness of absence, darkness of waiting. A vast, cold cloud drifting through space, light years wide, filled with hydrogen, helium, and dust so fine, it's like the whisper of ancient breath. This cloud is nearly empty, far emptier than any vacuum we could make on Earth. And it's cold, so cold that if you could float there, you'd feel the universe's patience pressed against your skin. 260 degrees below zero, just a breath above the coldest possible cold. But here's the secret. Within this silence, gravity is awake. Slow, patient, inevitable. Think of gravity as the universe's gentle hand, gathering scattered seeds after the harvest. It pulls molecule by molecule, atom by atom, drawing the cloud inward like a tide that never stops. The more it gathers, the stronger its pull. The stronger the pull, the faster things fall together. This is happening right now in the Orion Nebula. In pockets of that glowing cloud, darkness is collapsing, preparing to crack open into light. These collapsing regions, these cosmic eggs, we call protostars. A protostar is neither star nor planet. It's something in between. Something becoming. Picture a newborn bird still curled in its shell, gathering warmth, heartbeat rising, not yet ready to sing. Gravity keeps pulling, gas and dust fall inward. Every collision makes heat, like rubbing your hands together on a winter morning. The protostar grows denser, hotter, heavier. It's a cosmic furnace in the making, hidden beneath veils of dust so thick we can't see it with our eyes. But we've learned to see in other ways. Infrared telescopes, eyes that see heat instead of light, peer through the dust and reveal what's hidden. Hundreds of protostars tucked inside the Orion Nebula, each one gathering itself, each one preparing for the moment. And something extraordinary happens as they grow. From their poles, jets of gas shoot out, cosmic fountains, sometimes stretching a full light year long, moving at hundreds of kilometers every second. These jets carve glowing trails through the surrounding cloud, announcing something is being born here. We call these glowing scars Herbig Haro objects, signatures of creation in motion. The protostar is hidden, but its presence is undeniable. Like a seed beneath the soil, invisible but growing. Like a whisper of the cosmos, the universe whispers, "Wait, watch, light is coming." The critical moment, the point of no return. Inside the protostar, the temperature climbs, pressure mounts. What was once scattered across light years is now compressed into a space smaller than our solar system. The core grows denser than anything you've ever touched. And then, at a precise, beautiful threshold, the core reaches 10 million degrees Celsius. At that moment, the impossible becomes possible. Hydrogen atoms rushing through the heat collide with such force that they fuse together. Two become one. Hydrogen becomes helium, and in that fusion, energy, tremendous blazing energy, pours out. This is nuclear fusion, the same fire that powers stars, the same force humanity has tried to tame in our laboratories and our bombs. But in the heart of a protostar, it's not destruction, it's balance, it's birth. Before fusion, the protostar was falling, collapsing under its own weight. But once fusion ignites, the outward push of energy meets the inward pull of gravity, and for the first time, the two forces balance. The protostar stops collapsing. It steadies. It breathes. A star is born. This is what happened to Rigel, Betelgeuse, and every star you see at night. Billions of years ago, they too were seeds in the dark, waiting for the moment to crack open. And right now, in the Orion Nebula, this same miracle is unfolding. Stars hatching like sparks from an ancient forge. In the early 1900s, two astronomers, Einar Hertzsprung and Henry Norris Russell, asked a simple question. If we plot every star's temperature and brightness, what pattern will we see? What they discovered was beautiful. A story written in data. Most stars fell along a diagonal line. dim and cool at one end, blazing and hot at the other. They called this the main sequence, the long, steady chapter where stars spend most of their lives, fusing hydrogen into helium, balancing gravity with light. Our sun sits on this line. It's been there for 4.6 billion years. It will stay there for 5 billion more. A slow, patient burn, like a candle meant to last through a long winter night. But massive stars, stars like Rigel and Betelgeuse, don't follow this gentle path. They live differently. They burn faster. They don't whisper, they shout. Why? Because the bigger you are, the harder gravity squeezes. And the harder gravity squeezes, the hotter your core must burn to push back. And the hotter you burn, the faster you consume your fuel. A massive star lives like a match struck in the wind, brilliant, brief, unforgettable. Here's the cosmic rule, simple and strange. A star's brightness doesn't grow evenly with its mass, it explodes. Double a star's mass, and it doesn't shine twice as bright. It shines 16 times brighter. Why? Because gravity demands more pressure. Pressure demands more heat, and heat drives fusion at an exponential pace. Rigel has about 17 times the sun's mass, but it shines 120,000 times brighter. It's not just bigger, it's ravenous. It consumes hydrogen in great gulps, burning through fuel the sun would stretch across billions of years. So while our sun will live for 10 billion years, Rigel may be 10 million, 1,000 times shorter, a cosmic blink. The lesson echoes what Orion's myth whispered. The brightest flames are also the briefest. Power and longevity do not walk hand in hand. The universe offers a choice: shine gently and last, or blaze fiercely and fade. And isn't that true everywhere? In stars, in lives, in the moments we choose to burn bright or hold steady. So why do some stars last forever while others burn out? It's their mass. The massive ones burn fast and die young. The small ones simmer for eons. Orion, the greatest hunter, fell first. The stars teach us the same truth the myth did. The birth of Orion's stars. Let's travel back through time to when the Orion constellation was young. 10 million years ago, the stars we now see as Rigel and Betelgeuse were not yet born. Instead, there was a nebula thick with gas, alive with the slow collapse of clouds. And from those clouds, stars began to hatch. The massive ones came first: Rigel, Betelgeuse, the bright stars of the belt, each one igniting its fusion furnace, each one flooding the nebula with light and radiation. They were, and still are, the elders of this stellar family. But smaller stars were born too. Stars dimmer, cooler, slower to burn. Some of them are still being born today, tucked inside the Orion Nebula's dusty pockets. And those small stars, they'll outlive Rigel by billions of years. They'll still be shining long after the sun dies, long after Earth is gone. The Orion constellation is a family portrait. Grandparents nearing the end, children just beginning, and infants still curled in their cosmic eggs. It's a time capsule, a story still being written. The stellar nursery. The Orion Nebula is only 1,500 light-years away, close enough that we can watch it in exquisite detail. And what we see is astonishing. At its heart sits the trapezium, 4 bright, hot stars arranged like jewels. They're young, only a few 100,000 years old, and they blaze with ultraviolet light so intense it ionizes the hydrogen gas around them, making it glow pink and green. A cosmic announcement. Life is here. But beneath the visible glow, hidden in darkness, are the Boke globules, small, dense clouds, each about the size of our solar system. Inside each one, a protostar is forming. Gravity is pulling. Heat is building. Fusion is approaching. In infrared light, we can see them, glowing faintly, like embers beneath ash. Hundreds of them, each one preparing to crack open, each one a seed waiting for its moment to bloom. This is not history. This is now. Stars are being born as you listen. The Orion Nebula is not a museum. It's a maternity ward. And every time you look up at Orion's sword, you're not just seeing stars. You're seeing the nursery, where the next generation is being rocked to life. The connection to the myth. So let's pause here and notice something beautiful. The ancient Greeks looked up at Orion and told a story about death. A hunter struck down, transformed into stars as a final mercy. But what they were actually looking at, without knowing it, was a place of birth. One of the most fertile star-forming regions in our galaxy, a womb glowing with new light. Was this coincidence, or did the ancients sense something deeper? That life and death are not opposites, but partners in the same dance. Because here's the truth. For a star to be born, something else must fall apart. The gas and dust in the Orion Nebula, it came from older stars, stars that lived, died, and scattered their remains across the cosmos. The heavy elements that make planets, that make life, were forged in the hearts of dying stars and flung into space when they exploded. The death of one star seeds the birth of the next. Stellar evolution, the life and death of massive stars. Let me ask you something. How long do you expect to live? 70 years? 80? Maybe 100 if you're fortunate and careful. Now imagine a different world one where the strongest, fastest, brightest people lived the shortest lives, where power came with a price and the humble, quiet ones outlasted empires. That's the universe of stars. A red dwarf, a tiny, cool star barely glowing, might live for 100 billion years or more, longer than the universe has existed so far. The universe simply hasn't been around long enough for any red dwarf to die of old age. They're still children, all of them, waiting patiently in the cosmic garden. Our sun, medium-sized and steady, will live about 10 billion years. We're halfway through, middle-aged, settled into the rhythm of burning hydrogen, day after day, century after century. But Rigel, Betelgeuse, these giants, maybe 10 million years total. Already dying, already approaching the edge. Why such a difference? Because the brighter you burn, the faster you fade. It's written into the physics of fusion. It's written into the architecture of matter. And maybe, just maybe, it's written into the nature of all things that shine. Nuclear fusion, the cosmic furnace. At the heart of every star is a balancing act, a tug of war between gravity pulling inward and fusion pushing outward. Think of it like this. Gravity is the weight of the world pressing down. Fusion is the fire beneath, holding it up. As long as the two are equal, the star stays steady, a candle burning in a windless room. But here's the catch. The more massive the star, the harder gravity squeezes. And to push back against that crushing weight, the core must burn hotter, much hotter. And when the core burns hotter, fusion doesn't just speed up a little, it accelerates wildly, exponentially. A star twice as massive doesn't fuse hydrogen twice as fast. It fuses it hundreds, even thousands of times faster. Rigel's core is an inferno, hotter, denser, more violent than the sun's. It tears through hydrogen like a wildfire through dry grass. In the time it takes the sun to burn a single match, Rigel burns an entire forest. And so Rigel's life, brilliant as it is, will be brief. The universe offers no shortcuts. Brightness demands fuel. Fuel runs out, and when it does, the star must change or die. Life beyond the main sequence. Eventually, for every star, the hydrogen in the core runs out. For the sun, that moment will come in about 5 billion years. When it does, the furnace will flicker. Gravity will start to win. The core will collapse, squeezing tighter, heating up. And as it heats, something new becomes possible. Helium begins to fuse. The star swells into a red giant, bloated and unstable, before finally shedding its outer layers into space, leaving behind a small, hot ember called a white dwarf. But for massive stars like Rigel, the story is different, wilder, more desperate. When Rigel's hydrogen runs out, it doesn't gently expand. It roars into a frenzy of fusion. Helium fuses into carbon. Carbon fuses into oxygen. Oxygen into neon. Neon into magnesium. Magnesium into silicon. The star becomes an onion, layers upon layers, each shell fusing different elements, each one creating heavier atoms than the one beneath it. And at the very center, iron, the end point, the place where fusion finally stops paying dividends. The iron layers, the final days. Iron is special. It's the most stable nucleus in the universe. Fusing iron doesn't release energy. It costs energy. It's a dead end. The nuclear furnace has painted itself into a corner. At this point, the star's core is a ball of iron and nickel, about the size of Earth, but with a mass greater than the Sun. And it's no longer producing the outward pressure needed to hold the star up. Gravity wins. The core collapses, not slowly, but catastrophically. In less than a second, it implodes. Electrons are crushed into protons. Matter itself is squeezed into a space so dense that a teaspoon would weigh as much as a mountain. And then the universe rebounds. The collapse halts. The core bounces back. A shock wave rips outward, tearing through the star's outer layers, accelerating them to a fraction of the speed of light. The star doesn't just die, it explodes. A supernova. For a few weeks, that single dying star shines as brightly as an entire galaxy. Billions of stars worth of light concentrated in one final, magnificent scream. And in that explosion, something miraculous happens. All the heavy elements, gold, silver, carbon, oxygen, calcium, iron, are forged and flung into space. The building blocks of planets, the ingredients of life. Every atom in your body, heavier than hydrogen, was born in the heart of a dying star and scattered into the cosmos by a supernova's last breath. You are made of stars that died so you could be born. And now we see the answer to our final question. What does Orion's story teach us about mortality and purpose? The death is not an ending, it's a transformation, a scattering, a planting of seeds for what comes next. The supernova question. So, when will Rigel explode? When will Betelgeuse end its long, patient burn? The truth is, we don't know. Rigel might have already exploded. The light from that explosion might be traveling toward us right now, crossing the 860 light years that separate us, bringing news of an ending that already happened before your grandparents were born. Or it might explode tomorrow, or in 100,000 years. We can't say with certainty. These massive stars are unpredictable in their final moments, pulsing, swelling, shedding mass, flickering like candles in a drafty room. Betelgeuse is even closer, 640 light years away, and even more unstable. Astronomers watch it carefully, waiting. Its brightness changes, its surface ripples. Something is building. When it finally goes, and it will be one of the most spectacular events in human history. Imagine a new star appearing in the sky, as bright as the moon, visible in daylight, casting shadows at midnight. You could read a book by its light. For weeks, the night would be rewritten, and then, slowly, it would fade. The explosion would spread outward, a glowing shell of debris expanding into the void. And Orion, the hunter we've known for thousands of years, would never look the same again. But here's the beautiful part. That death won't be the end of Betelgeuse's story. The cycle continues. In the distant future, the gas and dust it scatters will drift through space, cooling, mixing with other clouds. And someday, millions of years from now, gravity will gather those remnants together. New stars will form, new planets will coalesce, and perhaps, on one of those worlds, someone will look up at their own night sky and wonder at the patterns they see. The cycle continues forever. We started with a story, a hunter, a scorpion, a fall, and a goddess who asked the sky to remember. The Greeks told this myth because they understood something deep, that pride without humility leads to collapse, that even the greatest among us are part of something larger, that mortality isn't a punishment, it's a passage. But they didn't know what we know now. They didn't know that the stars they saw were not eternal, that those points of light were born, lived, and would someday die. That within Orion's sword, new stars were hatching from cosmic eggs, that the atoms in their bones, and ours, were forged in the furnaces of dying suns. They told a story about death, but they were looking at birth. They told a story about endings, but they were looking at transformation. And maybe, just maybe, that's the truest thing of all. Because you are made of stardust, literally. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was born in the core of a star that died billions of years ago. When our sun finally exhausts its fuel, it will swell into a red giant, consuming the inner planets, scattering its outer layers into space. And that material, some of which was once Earth, once oceans, once forests, once you, will drift into new clouds, new stars will form, new worlds will bloom. In a very real sense, we are immortal. Not as individuals, not as bodies, but as matter, as stardust, cycling endlessly through the cosmos, transformed again and again, woven into new stories. And so, dear traveler, we come to the end of our first journey together. Tonight, we met Orion, the hunter who boasted too loudly, fell to a scorpion's sting, and was lifted into the heavens as both warning and wonder. We learn that stars are born from clouds of gas, protostars gathering in darkness, until the moment fusion ignites and they crack open into light. We learn that the brightest stars burn fastest, consuming their fuel in cosmic gulps, while the humble red dwarfs simmer for eons. And we learned something profound, that we, you and I, are made of stars. Every atom in your body was forged in the furnace of a dying sun and scattered across the cosmos billions of years ago. Death becomes birth. Endings become beginnings. The hunter falls, but from his fall, new light rises. This is just the beginning. Our journey through the night sky has only just started. In the episodes to come, we'll explore more constellations, more myths, more cosmic wonders. We'll chase Scorpius across the summer sky. We'll fly with Cygnus the swan along the Milky Way. We'll meet Leo the lion and learn why the great Sphinx of Egypt has been staring at the horizon for 4,500 years. If you'd like to continue this journey, subscribe. We'll be here, waiting beneath the stars, ready to wander together. You might be wondering why we call this place the Sleepy Circle. It's simple, really. The cosmos moves slowly, patiently. Stars take millions of years to form. Light takes centuries to reach us. And here, in this space we've created, we move at that same gentle pace. No rush, no urgency, just wonder, curiosity, and the quiet joy of looking up at something bigger than ourselves. Before you go, I'd love to hear from you. Which part of tonight's journey found its way into your heart? Was it the myth of Orion, the reminder that pride needs humility? Was it the Orion Nebula, that cosmic nursery where stars are hatching even as we speak? Or was it the realization that you, yes, you, are made of stardust, literally connected to every star you've ever seen? Leave a comment below. Share what resonated. Share what surprised you. Or simply say hello. You're not alone here. We're all looking up at the same sky, all made of the same ancient light. Oh, and one more thing, a secret just between us. You know how Orion is always chasing the Pleiades, those seven sisters, across the sky? How he rises in the east, marches westward all night, and sets in the west, never quite catching them? Some people say it's tragic, an eternal hunt that never ends, but I think I think Orion knows something we're still learning. Maybe the point isn't to catch what you're chasing. Maybe the point is the journey itself, the rising, the crossing, the nightly adventure, and then, after a few hours rest beneath the horizon, getting up and doing it all over again, simply because the chase is beautiful. And maybe that's not a bad way to live. Sweet dreams, dear traveler. Keep looking up. And remember, you're made of stars. Every single atom. You've always been part of something infinite. Until next time, keep chasing your Pleiades.